We will be starting with the third part of the chapter Heat. The topics that would be covered are conduction and convection, followed by conductors and insulators. The process by which heat gets transferred from the hotter end of an object to its cooler end is known as conduction. This process mostly occurs in solids. It is seen in case of only those solids which are good conductors of heat. We will see some examples of conduction process. In this picture, we have a metal pan. We can see that the heat from the stove gets transferred from the bottom of the pan towards its handle, and when we touch it, we feel it is hot. This occurs due to conduction. In this picture, we can see that the heat from the burner passes from one end, that is the hotter end, to the colder end of the metal rod. And when we test the temperature, we see that it is increasing gradually from the left end of the rod where we have the burner. The upcoming video explains furthermore examples of conduction.
Conduction. In this module, you will learn how heat is transferred by the process of conduction. When a pan is placed over a burner, the contents of the pan become hot. Why? This is because heat flows or gets transferred from the burner to the pan. The flow of heat through a solid is known as conduction. Let us try to understand conduction with the help of a simple activity. For the activity, you need an iron rod, a stand, some iron nails, a candle, and melted wax. Now fix the iron rod on the stand as shown. Then dip the head of the iron nails in the melted wax and stick them at equal distances on the iron rod. Then light the candle and place it at the other end of the rod. Wait for a while. What do you observe after a while? The nail closest to the candle will fall off the rod first, then the next nail, and so on. Thus, heat energy gets transferred from a hotter region to a colder region. But how does heat transfer occur? When a solid is heated, the molecules at the heated end start vibrating and transfer the energy to the next molecule. Thus, heat energy spreads uniformly throughout the rod. During conduction in a solid, heat is transferred along the body of the solid from one particle to another without the movement of the particles. Hence, conduction is defined as the flow of heat through a solid without the actual movement of the solid. Do all substances conduct heat the same way? No. Substances that conduct heat well are called good conductors of heat. Generally, all metals are good conductors of heat, and substances that do not conduct heat are called poor conductors of heat or insulators. Poor conductors of heat or insulators.
The second mode of heat transfer is convection, in which heat gets transferred by the movement of particles of substance away from the source. It takes place in liquid and gases and requires a medium. In this picture, we can see the water boiling in a kettle. The red arrow shows the hot water particles moving up, and the blue arrow shows the cool water particles moving down in a cycle, thereby heating up the water completely in the kettle. The other example taken up is the formation of wind by convection current. The warm air above the warm land, being lighter, rises up, and the cool air from the surrounding takes up the space left by the hot air, leading to formation of convection current and the formation of winds thereby.
Convection. What is convection? Convection is a mode of heat transfer which includes the movement of the molecules in liquids and gases. Convection does not occur in solids because the molecules in solids are tightly packed and are not free to move. For example, when water is heated in a vessel on a stove, the water at the bottom is heated first. It rises to the top and the cooler water flows down to be heated. This process continues and heat is transferred throughout the liquid. Natural convection is a natural mechanism where the density of fluid decreases on heating and then rises. The fluid on top, which is cooler, then moves down and replaces the heated fluid. This process continues and forms a convection current where heat energy from the bottom is transferred to the top. The driving force for natural convection is buoyancy, a result of differences in fluid density caused by temperature variations. In forced convection, the fluid movement is generated by an external source, such as a fan, pump, and so on. This method of heat transfer is efficiently used in air conditioners, microwave ovens, and so on. To understand convection in liquids, let us perform the following experiment. Take a beaker containing a small quantity of water, drop a large potassium permanganate crystal into it, ensuring that the crystal is placed at the center of the beaker. Notice that the crystal starts dissolving in the water. Slowly pour some more water into the beaker without disturbing the position of the crystal. Now use a low flame Bunsen burner to heat the water. Observe that the colored water starts rising from the place where heat is supplied. Molecules of hot water vibrate faster, and therefore when hot molecules strike the colder molecules on the way up, they transfer their energy to them. Soon the vibrations reduce and the rising water becomes cold and heavy and comes down along the sides of the vessel. After it reaches the bottom, it gets heated again and rises up, creating a convection current. Convection in gases. Let us take the example of sea breeze. During the day, Earth's surface gets heated faster than sea water. The air close to the ground absorbs heat from the surface, becomes lighter and rises up. Air from the sea, which is cooler and heavier, immediately rushes to replace the hot rising air. This air again gets heated and rises up, and a cycle is set up. This cycle is called convection current. Now let us perform the following experiment to show convection currents in air. Take a closed rectangular box with a removable glass front and two wide glass tubes projecting from the top. Place a burning candle below one tube. Now hold a smoldering piece of paper inside the second tube, allowing smoke to enter the box. Smoke shows the direction of air flow. Notice that the smoke moves inside the box, gets heated by the candle, and rises up through the first glass tube. This occurs because as the air above the candle gets heated, it loses density and rises up. Cool air is sucked in through the second tube. This creates a convection current inside the box. This method was often used to ventilate coal mines. Application of convection. Ventilators in homes allow the warm air that we breathe out to escape. Cool and fresh air through doors and windows then replaces this hot air. Heaters used in homes also create convection current to heat the rooms.
Summary of what we learned today. The process of transferring of heat from the hotter end to the colder end of an object is known as conduction, and it requires a medium. Generally, the heat is transferred in solids by the process of conduction, but applicable to only those solids which are good conductors of heat. We saw some examples of conduction and its application. The method of transferring heat by the movement of the particles of substance away from the source of heat is known as convection, and it occurs in liquids and gases. Convection also requires the presence of a medium. We saw some examples of conduction and its application. We also identified the difference between conductors and insulators.